In this lesson video, we are going to cover color models. Now, I must warn you that this lesson and the next one are theoretical lessons and not related directly to Blender. So if you want to skip ahead, you can do so without any problem. But if you watch the lesson, you may get some additional insight about how color works in the real world and in computer graphics. It will be beneficial if you need to work with any graphics applications in general. Color is one of the most important aspects of creating beautiful art and design. There are so many colors and color variations exist in the world. For centuries, we as humans have tried so hard to uncover the secrets behind colors. Why is this so important for us? Because by knowing how colors actually work, we can later capture them, store and digitize them, reproduce them, or display them precisely. We need to simplify the colors to their basic components, which are called the key colors. Using the combination of these key colors, we can reproduce any color that we want. This is what we call the color model. So basically, color models are methods of describing colors using a combination of key colors or using a set of parameters. There are two types of color models: light-based color models and pigment-based color model. Light-based color models use lights as the color producer. All devices that produce light use this color model. For example, computer monitors, smartphone screens, televisions, projectors, etc. There are two light-based color models we are going to discuss in this lesson video. They are RGB and HSV, okay? Next is the pigment-based color model. Unlike the light-based color model, the pigment-based color model uses inks or paints to produce color. Everything that is printed uses this color model. The most common pigment-based color model is CMYK. Let's discuss the light-based color models first, and then later the pigment color model. RGB, as I mentioned before, is the color model for lights. RGB stands for red, green, and blue. By using these three key colors, we can produce any colors that we like. If all of the colors, red, green, and blue, all turned on to its maximum strength, the output color will be white. And if none of the RGB colors are turned on, then the output color will be black. So basically, in the RGB color model, black means off or no lights at all. If only the red and green colors turned on, then the output color will be yellow. If the green and blue are turned on and the red is off, then the output color will be cyan. If the red and blue colors are turned on while the green color is turned off, then the output color will be a light purple color. If the strength of each channel is uniform, then the output color will be grayscale colors. Other colors can be produced by controlling the strength of each channel. Okay, so that is the RGB color model. Now, although RGB is the true color model of lights, using RGB to pick a color is very unintuitive. If we need to select a certain color, we need to do a lot of guessing and trial and error process. That is why another light-based color model was introduced called HSV. HSV, which stands for hue, saturation, and value, is the derivative color model from the RGB color model. It is a light-based color model also. But unlike RGB, which divides the color into three main key colors, HSV uses color characteristics instead to define the color output. The first one is hue. This hue strip will display the color wheel. It is called the color wheel because it is a rotational value from 0 to 360 degrees. We can see that the red color in here is actually the same with the red color in here. The saturation value controls how much color present as opposed to grayscale colors. If we set this to the maximum value, the color will be at the strongest saturation. And if we set this to 0, there will be no color at all, or basically makes everything in the grayscale spectrum. Changing this saturation slider is the same as dragging the color pointer up here left and right, okay? The V slider here is for value. In other software, sometimes it is called B, which stands for brightness, or L for level. So basically, the terms HSB and HSV and HSL are all the same thing. The brightness value controls how much light is being emitted from the color. Changing this value or brightness slider is the same as dragging the color pointer up here, up and down. If we set this all the way to 0, we will have black color. Because in the light color model, as I mentioned earlier, black means dark or no lights at all. If we set this all the way up, the color will be at its brightest. The third color model is the CMYK color model. Unlike the two color models we have discussed earlier, CMYK is a pigment-based color model. If you own a color printer, most likely you're already familiar with CMYK because the ink cartridges of the color printer are based on this color model. Long time ago, we used to think that the key colors of pigment or paints are red, blue, and yellow, because a lot of colors can be produced by mixing these three colors. Some art schools even still teach this concept until now. Although you can achieve a lot of color variations with red, blue, and yellow paints, you cannot produce all of them. Scientists already discovered that pigments' key colors are more likely to be CMYK. C for cyan color, M for magenta color, Y for yellow color, and K, well, K actually stands for key color. But because most of the key colors are considered as black color in the printing industry, we can safely assume that K is for black. We need black color because cyan, magenta, and yellow colors, when mixed together, can only achieve brownish mud color. They can never achieve black color without a dedicated black ink. Now you might be wondering, are there any other pigment-based color models besides CMYK? Actually, there are, but mostly they are not commonly used color models, and they are proprietaries to certain printer companies. Some printer manufacturers release color printers that use more than 4 color components. They have unique color models but are still based on the CMYK color model. For example, a 6 colors hexachrome printer uses CMYK inks plus a dedicated orange and green inks. Another type of 6 colors printer uses the dark light method, meaning besides the CMYK inks, it adds a lighter shade of cyan and a lighter shade of magenta. There are also digital printers that use 8 or more base color inks. In this course, because we are focusing on 3D computer graphics, we are not going to use the CMYK color model. As we all know, 3D graphics are always displayed on screens which all use light-based color model. You can generate real objects from your 3D data using 3D printers or CAM machines. But this 3D printing process has nothing to do with the CMYK color model. Yes, you can render to an image and then print that image using CMYK printers. But commonly, you do this through 2D graphics software. This is the reason why in Blender you won't find CMYK color picker like the one you can find in Photoshop or Adobe Illustrator.